All right, so this video is to walk us through the first two examples in the guided notes for today. So in both of these equations, we have two radicals, not just one like we had in the problems last time. So whenever this happens, we're going to start by working to isolate one of the radicals. So this first one I'll choose to isolate the square root of x minus 3. So I'm going to do that by adding the square root of x plus 4 to both sides. And then I'm going to square both sides to undo the isolated radical. So that left-hand side is easy. It's the right-hand side that's kind of a problem because we're squaring something that has an addition inside of it. That means it requires something like foiling. So I'm going to write out what this means. And you could box this too if you wanted to. Negative 1 times negative 1 is positive 1. Negative 1 times the square root is minus 1 of those square roots. Negative 1 times the square root is another minus 1 of those square roots. And then the square root times itself is going to be like squaring the square root, so it would undo and leave me with what's inside. Now this looks a hot mess, right? There's a lot of stuff going on here. So what I want to do is combine like terms on that stuff on the right. So let's see, I've got an x, but there's no other x's that aren't under radicals. I've got a 1 and a 4, those combine to be 5. And then I've got negative 1 of these radicals and another negative 1 of these radicals. So if I'm putting those together, that would be negative 2 of those radicals. Now this is better than what we had before because instead of having two types of radicals, we are down to 1. So now we're going to loop back to the beginning of the process again and work to isolate that radical. So we're going to subtract x and subtract 5 from both sides. That goes away, that goes away. This happens to go away, which is nice. I'm going to divide both sides by negative 2. I'm going to square both sides to get rid of that radical. And then I'm going to solve the resulting equation. And then, of course, I'm going to check my answer. So let's see, 12 minus 3, and then 12 plus 4. Does that equal negative 1? Well, let's see, that's the square root of 9. That's the square root of 16. So that's 3 minus 4, negative 1. Yes, so this is the answer. So let's look over at the second problem. Same exact process. There's going to be one slight complication further down. So we're going to isolate one of the radicals. I'm going to choose to get x plus 2 by itself, although it doesn't really matter. I'm going to square both sides. On the left-hand side, that square is right up against that square root, so it leaves me just with what's inside. But on the right-hand side, I'm going to have to FOIL this out. So I've got x plus 2 equals, this is going to be 36. This is going to be negative 6 times that square root. This is also going to be negative 6 times that square root. And then the square root times the square root is going to leave me with what was inside. I'm going to combine like terms on the right. So let's see, I've got a 2x. I've got a 36 and the 5. And then I've got negative 6 of that root and negative 6 of that root. Now I've got an equation that has one type of radical in it, so I'm going to work to isolate that. I'm going to divide both sides by negative 12. Now, when I do this, you're going to see me do something that I really highly recommend you do. So all those things in that fraction are negative, right? so I can make them positive. I am not going to break that up into 1/12x plus 29 over 12. I'm going to leave it like this, and you'll see why in a minute. Now, I'm going to square both sides to get rid of the radical. The thing on the left-hand side is x plus 29 squared over 144, and this thing on the right-hand side becomes 2x minus 5. I'm going to multiply both sides by 144. Oh, it's 5 times 144. Let's see, 0 carrier 2, 720. And then I'm going to FOIL out the x squared plus 20, the x plus 29 squared. And that will give me x squared plus 58x plus 841 equals 288x minus 720. Now this is a quadratic, and I know it's got some big numbers in it, but we're going to go ahead and solve it. So we're going to subtract 288 from both sides. So 288x from both sides. And we're going to add 720 from both sides. This looks like it would be a pain to try to like factor. So I'm actually going to do the quadratic formula here. So it's 230 plus or minus 230 squared minus 4 times 1 times 1561 all over 2 times 1. Now I'll tell you, underneath the radical, you should get 46,656. Which happens to be a perfect square. That is the perfect square of 216. So, mess that up a little bit. So 216. Now, that's supposed to be a 230 there. So that's 230 plus or minus 216 all over 2. Now, 230 minus 216 is 14 over 2, so that's 7. And 230 plus 216 is 446 over 2, which is 223. So I'm going to take those and plug them in and see if they work. So when I plug in 7, I would get 14 minus 5, which is 9. So I'm checking 7. Plus 7 plus 2 is 9, so square root of 9. So let's see, that's 3 plus 3, which is 6. So 7 works. 223, if I plug it in, let's see. 223 times 2 is 446 minus 5 is 441 plus the square root of 225, and that is 21 plus 15, and that's 36. So that one doesn't work. By the way, a cue that you got an extraneous solution, if I were to change the sign of this thing right here, it would have worked, but it doesn't because the sign is positive there. All right, so we'll come back together.